In CP3-6, we're going to learn how to calculate arc lengths. And it's really important that you know the distinction between the measure of an arc and the length of an arc. So when I'm talking about the measure of an arc, if I've got a circle and I want the measure of this arc, that's this angle, right? It's the same as that central angle. The length of that arc, though, doesn't rely on the central angle. It's as if I laid a tape measure along the outside of the circle and found, well, how many inches is that, right? So length is going to be in inches or centimeters or miles or feet. Measure will be an actual angle measure. So it'll be in degrees, eventually radians, but for now, degrees. And we're going to think of it as fraction of the circle. So if I know the diameter is 24 centimeters, I can quickly figure out then that the circumference of each is 24 pi centimeters, because my circumference is just diameter times pi. If I have 180 degrees, I need half of that. So half of 24 pi, my length must be 12 pi. And if I have a measure that's 90 degrees, well, 90 degrees is 1/4 of the circle. The whole circle is 24 pi. 1/4 of 24 is 6 pi. So this length must be 6 pi. And if I'm keeping just 120 degrees of it, well, that's 1/3 of a circle. The whole circle was 24 pi. And 1/3 of 24 is 8 pi. So hopefully you notice a pattern that we're going to take what fraction of the circle we have times the circumference, and we'll get just the length of the arc. So if I'm asked to find the length of arc B, AB rather, when there's 2 letters, I'm always going the shortest route between the 2. When I have 3 letters, so let's say they put C out here and they said they want the length of arc ACB, that's when I use the big way around. So quick refresher there if you did not recall. And I have 60 degrees out of 360. My radius is 12. So that means my diameter is 24 and my circumference is 24 pi. I'm going to clean this up just a little bit. My zeros drop out. 6 over 36 is the same as 1 over 6. And 24 divided by 6 is 4. This time we're asked to find the length of arc GF. So I want to know how long this is. And they didn't draw on my central angle, but I actually don't need it because I still know my radius is 8, and the radius is 8 the whole way around. So I have 134 out of 360 degrees times the entire circumference. 8 times 2 is 16 pi. 16 and 360 are both divisible by 4, so I'm going to clear my fractions there. So I have 4 pi here. 360 divided by 4 is 90. Again, they're both divisible by 2. So I can clean things up just a little bit. I could also have simplified the 134 and the 360 first by clearing out a 2. And now I'm going to throw it in my calculator. 134 over 45. Take that answer times 2. And I'm going to round. Actually, I'll just write it as a repeating. If you have a calculator that easily converts into fractions, you could also keep that as a fraction, whatever floats your goat. One more example that we'll do just like that. We're looking for arc AC if angle B is 55 degrees. So this is 55. O to C is 10, so my radius is 10. Easy breezy. And some of you are sitting here and you're like, easy breezy, piece of cake, throw 55 over 360 times 20 pi, and you're painfully close. But remember, friends, that my inscribed angle, so the angle on the circle, is only half as big as my central angle. So this angle is 110 degrees. And the central angle is the one that matches the arc. So this isn't 55 out of 360, it's 110 out of 360 times that 20 pi. My zeros will drop out. 36 and 20 are both divisible by 4, so I get 5 pi over here, and I get 9 down here. If I multiply straight across, I get 55 pi ninths. If I wanted to leave it as a decimal, I get 6.1 repeating pi, or I could have 6 1/9 pi, any of those.